about 15 minutes past the hour, so we're going to go ahead and get started. The theme of this webinar was what's new with Data Classroom, and just realized that over the past year, we've had a lot of new releases and upgrades to the platform, and some of them are subtle or kind of out of the way, and a lot of that is by design. But that also means that someone who's a longtime user of the platform, has had their students working with Data Classroom for a couple of years now, may have missed some of the new stuff. So we just want to take some time to cover that. Also want to acknowledge that if you're whether you're coming to us from the university world or you're coming to us from the K-12 world, just want to acknowledge that we have two different versions of the platform. We have Data Classroom and we have Data Classroom U, which is the additional college level features. If you are a K-12 teacher, you can switch back and forth between university level feature set and the K-12 feature set. And I'll show you how to do that today during the webinar. So with that, let me just give you a quick outline of the things that I plan to cover. And again, if you have questions, we can see some additional things as well. So today I was planning on showing the new edition of the correlation matrix. This is very, very new. This has only been out for a couple of weeks now. We also have the melt function, and this has been out a little bit longer, but it's kind of out of the way, and it's very useful if you're having students tidy up data, particularly when they've split the same variable across multiple columns. And we'll show you how to use the melt function. This one's really, really subtle, and this is that we now have the ability to group numeric variables, and this really comes into play when you're trying to do sort of per data point error bars, or you're trying to see the mean of different treatments that are numeric, and I'll show an example of this. And then finally, just want to show a little bit of bridge to R and now bridge to Python. This is a new addition, and so we provide a springboard for students who are wanting to learn some R coding. And that's been out for a little while, but the Python part of that is completely new. So with that, I'm going to go ahead and stop my share for a second, and then I'm going to reshare with Data Classroom on my screen. 1 second. Share screen, and well, that wasn't as smooth as I would have liked. Hold on 1 second. And this is the screen I wanted to share with you. Yeah, you would think this is my first Zoom. It is not. So going to take you through the correlation matrix first. So the correlation matrix is really good when you want to get the overall picture of a data set that has a lot of numeric variables, and it'll allow you to show which numeric variables are correlated with each other. There's a lot of reasons you might want to know this. You might just be exploring the data and wanting to see what looks interesting in it. You might be planning to build, say, a multiple linear regression model, and you're concerned about how some of your variables might be overly correlated with one another. No matter what the case, though, it is easy to see a lot of information through a correlation matrix. And I'm going to open up a data set that I had loaded to play with this. This is a miles per gallon data set from different vehicles. And these vehicles are all, I think, from 1970 through 1982 is their model numbers. And this is the core data set area in Data Classroom. We can, of course, jump to graphing, and we can see some of these correlations. Like if I wanted to see the correlation between maybe, say, vehicle weight and vehicle horsepower, we could plot this on a standard XY plot. I could add a line of best fit. I can get parameters like my R squared of 0.74 in this case. So we can see an obvious correlation here, or perhaps a correlation between horsepower and 0 to 60 time in seconds. We can see that the more horsepower the engine has, the lower or smaller 0 to 60 times. So we see a negative correlation here. But if we want to explore the data set all at once, this is where the correlation matrix comes in. And you get to this by this hamburger menu, this left-hand tool menu. So up on the white bar here, this thing that looks vaguely like a hamburger, the 3 bars. If I click that, you'll see down at the bottom of the menu, this option for advanced options. And I gotta say, from a design standpoint, this is where we've been adding some things that don't fit into our core paradigm of you want to plot the data on an X and Y axis and look at it first. This is for things that don't quite fit with that paradigm. And when I open this, you'll see a couple of things in here. You'll see hypothesis tests. So if you want to skip graphing and go straight to stats, you can do that. The tidy data or tidy format melt, and we'll come back to that. But you also see correlation matrix. So I'm going to pick that for a second. And when we come into the correlation matrix, I had played with this data set. So let me just strip this down to default again. This is what it'll look like when you enter. And you can add any number of numeric variables. All your numeric variables will be displayed here on the left. And we can see here's miles per gallon and number of cylinders. So we can start to add those. As soon as we get 3, it will build us a tiny correlation matrix. And we can see we have this matrix here where each square in the matrix is showing us what the correlation is between the two. And that's the big number at the top. Things that are perfectly correlated will be 1.0. And I'm going to go ahead, I'm going to add all of these numeric variables to this matrix. And we can see there is also this button to customize appearance. So if I come over here, this will let me change a lot of things. And again, this was not default. I had played with this. The default will give you all just shade of a single color. And so the stronger the correlation, the darker the color. And you can see that the matrix is, the full matrix is a square, right? Where we have all of the variables on both sides. It's often easier to think about by just looking at half the matrix at a time like this, because it's a mirror image across that diagonal. And you'll notice the whole diagonal is 1.0 because miles per gallon is perfectly correlated with miles per gallon, and number of cylinders is perfectly correlated with number of cylinders itself. And so that's what the diagonal is. And then you'll see various shades as you go on. You also see the default option will not show you p-values. It will just show you the value of the correlation. And when you click show p-values, it will show those pictured. And the default will be to have those corrected. And what that means, if you're not familiar with corrected p-values, and what they're corrected for is multiple comparisons. Because if you think about it, with the threshold of 0.05, if all else is equal, if you are randomly conducting 20 separate tests, you would expect roughly one of them out of 20 to give you a p-value below 0.05, just through random chance alone. And so what this does is this is dividing the p-value by the number of comparisons that you have. This is a very common correction called the Bonferroni correction. And it a lot of times will raise the p-values. Now this has a lot of really strong correlations in it, and the data set is fairly large. So we see, even with the corrected values, we see a whole lot of p-values that are very low, less than 0.000 or 0.001 in value. So there's quite a few significant p-values in there. Yeah, Lee, thanks for your comment. I appreciate it in there. So yeah, this is quite handy when looking at a lot of numeric variables at once. Any questions on the correlation matrix before I show you the melt?
Aaron, I see at the top you have the Spearman there. Is what are the other, okay, we have a couple options.
Yeah, you have the Pearson, and I apologize for not showing this. I should have gone right to the start with this, but the Pearson correlation is more of a traditional correlation between numeric variables. This, when we think about a correlation in a line of best fit and an R value and an R squared, this is typically what we're talking about is this Pearson correlation coefficient. Spearman's rho is for non-monotonic correlations. So these are correlations where the values of the data are not necessarily on a scale where every unit is exactly equal to each other. And so this is often used in survey data where you say, hey, rank something 1 to 5. Well, the units there start to lose their numeric meaning. But what this does is looks at the data in ranks and sort of says, hey, as the value of one of these ranks move up, does the value of the other variable move up as a rank? And so this is a nice tool to use with a lot of survey data. If it's just straight, measurement data and like the data we see here in this example data set, probably the Pearson is a better fit. And oftentimes I'll also say the story that they'll tell you is not often dramatically different from one another. Often they'll tell you something very similar, but you have these two options. And again, I think with something like survey data, Spearman's rho is a really good option for that. So thanks for the question. Okay, I'm going to pull up another data set and show the melt. So I'm going to return to my dashboard for a minute. And back in my dashboard, I'm going to pull up another data set, one that I have titled Melt This File. So we can just see what this data looks like. And this is actually data from a high school science fair project. And let's just take a look at this data set for a second and look at the structure, right? The columns that the student has named is day, and they have 9 different days numbered down here. And then they have 4 other columns that they've labeled no plastic, 10% plastics, 50% plastics, 100% plastics. And this I think is a really common way that you might see data formatted if you leave students to their own devices. It seems logical. It's with smallish data sets, it's easy for the human eye to read, but it's got a couple of problems when you try to apply computing power to it. And there's a couple of things about it that distinctly make it not tidy data. And one of those is that each variable doesn't have a single column. And the other thing is there's some variables, and this goes part and parcel with each variable not having a column, but there's some variables that are not labeled. And so when we look at these numbers that fill in the majority of the cells in this data set, we don't necessarily know what those are, right? When we look down this first, under this no plastic column, we see 2, 3.35, 4.77, 5.45, but we don't know what these numbers represent. And so really this experiment has 3 variables. It has day number, and it has some kind of plastic treatment or plastic level. And that's what the 4 columns are, but that's actually one variable. So in tidy format, that would be in a single column. And then the other variable here is whatever these numbers represent. And I worked with this student, so I know that these represent height in centimeters of plants, but even though that variable of height is collected, it's not named anywhere on the data sheet. So we can tidy this up through the melt function. So once again, I'm going to go back over to the left-hand menu, and I'm going to go down once again to the advanced, and I'm going to go to this tidy format melt with the little dripping icon there, the little drop. And it's going to ask, select the columns you want to combine. And the picture to the left is kind of illustrating what's going to happen. If we've got the same variable spread across more than one column, we're going to melt it into the same column. And so this variable, no plastic, 10% plastic, 50% plastic, 100% plastic, these are all the same variable. And so I want to combine them. So now I go to the next step, And we're going to name our category column. So this category column, I'm going to call it plastic treatment. And this value column, I'm going to call this height in centimeters. And I'm going to go ahead and now I'm going to click convert in the bottom corner, the little purple button. And now we melted the data set. And if we were wrong about it, we can undo it up here. But this is in fact how we wanted the data set to look, where we can see now we have day, we have plastic treatment, and we have height. So we can very easily work with that and graph that. Let's plot height, let's plot it across day, let's color code it by plastic treatment. And, maybe let's connect those dots with lines. And, maybe this is an informative graph for that data. But before, when it was in the other format, the computer wants to know what variable to put on X and what variable to put on Y. So we would have only been able to show one of those treatments at a time. We wouldn't have been able to show, all four of those treatments at the same time. And I know, Excel and Sheets will let you put multiple columns on the same graph by highlighting, but I often think that leads to confusion. And sometimes it leads to some, disastrous graphs where students are plotting data from different parts of the spreadsheet as if they were the same variable, when in fact they're not. And this sort of forces students to think about, what variables are they working with, and then say, okay, what variable do I want on X? What variable do I want on Y? And if I want to group those by another variable, like in this case, plastic treatment, I can do that by adding this third variable that we're calling Z there. So that is the melt function. Any questions on the melt function? Just want to peek at the chat here. Okay, the next thing I wanted to show you was this ability to group numeric variables. And to do this, I'll save this in case we need to come back, but I'm going to go to the resource library. So I'm going up to my browse button and I'm going to the resource library. And I already had started searching this. So I have potato in my search bar up there. So the data set's already queued up. And I'm going to open up this data set. This is classic potato osmosis lab, where students are cutting up chunks of potatoes. They're soaking them in a sucrose concentration, and they're recording what the mass change was as a percentage. And when we go to graph this, if we let's graph mass change, and let's say sucrose concentration as a categorical variable. When we're doing this, and I know sucrose is actually numbers on X, but we are saying treat this as categories. And what that allows us to do is we can get descriptive statistics separate for each category. So like here's the median, or in this case, here's the mean and standard deviation, or maybe we'll do mean and 95% confidence interval. So this is how we can group categories. But previously with DataClassroom, if we changed sucrose concentration to a numeric variable, we weren't able to get descriptive stats previously, because these, we weren't looking at these in groups. And so if you wanted descriptive stats for each of these treatment groups, you were forced to set sucrose concentration as categories. But now if you check the descriptive stats check mark, it will show you descriptive stats for each group. And how this works is it's taking a look at your data and it's recognizing if your numeric variable is chunked up into discrete groups like this is. So you can see all of these numeric values on X are either at 0 or 0.2 or 0.4 or 0.6 or 0.8 or 1. There's none in between these sort of set bins. It recognizes this and now automatically gives you the option to do descriptive statistics. You can also, of course, I can hide dots if I want. you can get the option to join. And I think this is the specific graph that we were getting a lot of requests to be able to make of, can I make a graph like this? Well, now you can. And again, the computer will recognize if you've got a numeric variable that's grouped. After you add descriptive stats, you'll have the ability to join them. In addition to joining them, you can also still show a regression line on top of them. But just one note with this line of best fit is not actually a best fit from these means that you're seeing here, right? Because these dots are only showing us the averages for each level of sucrose concentration. That line of best fit is actually being calculated with all of these data points that you see here. Now, it's a real subtle difference. I'm quite certain if you looked at a line of best fit with just the means and you look at a line of best fit with all these data points, in this particular case, they're not going to be wildly different from one another. But this is just something to note that especially when you're doing a graph like this line of best fit is actually calculated with all the data, and you just want to make sure that you're not misleading your audience when you show that. Any questions on that ability to add descriptive stats on groups of numerics on X? Okay, I'll save this in case we want to come back to it. We'll call it potato osmosis webinar, and we'll save that file. Then the last newish thing that I wanted to show you is that we now have the bridge to R and bridge to Python. This is only available in the university or DataClassroom U feature set. Again, teacher accounts are able to move back and forth. Student accounts are licensed differently. So a student will either be on a DataClassroom U license or they'll be on a DataClassroom K-12 license. So if you want to change to this in your teacher account, if you go into your profile, so I clicked on my name and I'm going to profile and I'm going to change to college level. This will, now you see the color purple up at the top changed and the logo changed up here. So now I'm running DataClassroom U. I'm going to go to a data set and let me pull a different one. I don't know, for this, I'll demonstrate with this data set that's called Too Old to Mango. This is, by the way, this is the only data set on DataClassroom that's available in 2 languages. We have it in Hindi and in English. We did a trip to India with the U.S. Commercial Services, and so we've got that for a presentation we did. But I'm going to go to the English version because my Hindi is not very good. In this data set, I want to show you the bridge to R and the bridge to Python. So first thing you want to do is get into the graph, and I'm going to plot total sugar content, and I'm going to split that apart by tree age, and maybe I'm going to add some descriptive statistics to that. We'll do box plots beside the raw data, so we can see what we're looking at. So I've made this plot in DataClassroom's interface. And if I want to run stats in DataClassroom, and if some of you are new to DataClassroom, this is our graph-driven hypothesis test. And this will launch statistical testing from your graphing. And so it will take a look at this graph and say, okay, what do we have here? It looks like we have 3 groups, and we're comparing a number, which is total sugar percentage, and we're comparing it across 3 groups. So when I go and I click that button, it's giving us the hard recommend for the ANOVA. And this is the analysis of variance. And this table is explaining why we're assuming normality here. We've got more than 2 categories and we're comparing a number. and we can click calculate, and it will tell us, why are we using the ANOVA test? When should we use it? How does it work? It can give us our results. We can expand those with post hoc tests. We can look at the sums of squares and so on. But there's also this option, and you saw it in the first window as well when we open this, to try it in R or try it in Python. And so these are bridged to these two coding languages, which are becoming, increasingly popular in data science. My background's in biology. R is very, very common in biology. Python more common in engineering, or even systems biology, or sort of ecology with a capital E, as I say. But if we I'll click try it in R first, and you can see that this is the R script to make that figure that we made. And I clicked the run it in R, and this is not what I want in a demo. It looked like it failed to load that. So let's hit that again. And unfortunately, that's not working for me right now. I don't know what's going on with that. What's happening behind the scenes is it's taking this R code and it's sending it to our server, which is actually going to run R. Now, the graph we made in Data Classroom is not running in R. It's our own custom package that we put together. But this code will run in R. You can get the code for the graph. You can get the code for the hypothesis test. And just as I did it in Python, I'm going to tempt fate, and we're going to run it in Python as well. So this is the Python code over here. You can see I just ran the statistical test, and this is the result. The Python result is very sparse. It just gives you the F statistic, which is very high here at 80, and the p-value, which is 5 to the -31st. So very, very small. I'm going to run the graph as well in Python, and it will go ahead and it will run that graph in Python, which again is not working. So I apologize for that. And I have a phone call to make when I hang up here. But that is how you get the code to do these operations that you do in Data Classroom through these bridge features. So that is the extent of the new, the decidedly new stuff that I wanted to show you. I know we have some of you on the call who are a little bit newer to Data Classroom. But does anyone have any specific questions of something else they'd like to see while we are all here together?
Yeah, so it looks awesome. Really cool stuff. I think it's
Thanks.
really good for learners to do it this way. So you click on your graph, then you're wanting to do some stats, and it suggests the right stat tool for you to use. Is it possible to have students, can they go down a rabbit hole of using the incorrect stats unless they're reading about why they should be using that test and where it's appropriate, or will it kind of help correct them if they select something that they shouldn't?
Sort of, because the sort of algorithms, whether you're doing this, as a human or as a computer, that select the stats tests are kind of limited by the data type, right? So if you have categories on X and you have 3 or more, and you have a number on Y, you really only have 2 options here. You can run ANOVA, or you can choose to run a non-parametric test, which in this case, it would say run Kruskal-Wallis. But you can't, in this format, say, I want to run a chi-square goodness of fit, which operates just with categorical data only. It won't work. And this is, I think, sort of where, traditionally, if a student was trying to run one of these models and say R, they would just get an error message, and it wouldn't necessarily be very informative, and they wouldn't be able to run it. So in that way, they sort of can't run it. Now, there is one more avenue to run stats tests a little bit more free form, and that is over in the advanced menu. And this doesn't even depend on a graph. So if a student hasn't graphed their data at all, and so I can go to like this hypothesis test here, and it will just say, okay, you can pick one of these, and like for this, pick t-test, and then it will say, okay, if you want to do a t-test, what is your dependent variable? What is your independent variable? And so now, you can go down this, and if I say, I will say dependent variable is total sugar, and we'll say independent variable is tree age. Well, this one is actually selected because I did have something on the graph, so it'll fill it in there, but it'll tell you like, hey, this isn't going to work, and here's the reason. There's too few distinct categories in tree age to work as a t-test, so this is only going to work as an ANOVA. But for the most part, I think, personally, my personal philosophy in teaching this is, if a student is going to run a stats test, I want them to make a graph that is sort of poses the question in visual form. And so in this graph, if the question is, does total sugar differ across tree ages, I want them to make that graph looking at that first, because you can make a conclusion with your eyes before you've even run a statistical test. And you might say something like, well, it looks like the 6-year-old trees have less total sugar, and the 18 and 30-year-old trees have more and aren't very different from one another. That's not a statistical result, but that is very much in line with what the statistics will tell you. I always like to say your stats should never be a surprise if you've graphed your data first. That was kind of a long-winded answer. I don't know. Did that
was
answer your
helpful.
question?
Yeah, I think, visualizing it really helps tell the story and helps them understand where they're going with the stats. I think that, often they get a bit lost of choosing which stats, and this really helps them think through it. Yeah.
Yeah. And another thing I like about doing it this way, and when students use the tool on a regular basis, is they start to realize that, like, it's not magic which stats test you're to use. It's based on some pretty simple algorithms of, what type of data do you have, what type of distribution do you have, and also, I think it's also fair to acknowledge that even practicing scientists don't necessarily have all of those algorithms in their head, but they'll frequently, look up, what do I need to use in this situation, and that's completely okay.
And so you went back and you said, oh, I could do a non-parametric test, and that was just based on your graph.
Yeah, if you want to do, sorry, I cut you off. I'll let you finish your question.
It was just, figuring out the distribution and the assumptions of that data set. To visualize that as well, or?
So one way you can test the assumption of normality is if you view the data as a histogram. So just to I click that quickly. I'm looking at these as dot plots. If I switch over from dot line-based graphs to rectangle-based graphs, it'll give me a histogram, and there'll be an option right here to show normality. And once I do that, I can also test normality. I can do it each group at a time. So like I can do it for, the 6-year-old, the 18-year-old, the 30-year-old. I can do it. I've got 2 different choices of normality tests, and I can run that test. It'll give me a test statistic. It'll give me a p-value, and it'll give me some notes on how to interpret those. And in this case, you'd say, yeah, we can't reject the normality. These data appear to be normally distributed. The one assumption that testing that we don't have built in yet, although we have plans for it to come out in an update, is testing the assumption of equal variance across groups. So we don't explicitly have a test for that yet, but that is coming relatively soon.
Okay.
Yeah.
And the normality is only with the DataClassroom U, correct?
No, actually, I believe that is there in both packages. Here, I could verify that for you for a second. Save this. I switch back. Let me just check that. I believe that's available in both packages. So if I change back to middle high school and I go back to that same data set and we go right where we were. Let's see. and we go into graph. Yeah, that is available in both packages as well.
All right, thanks.
Sure.
I had one other question that I saw when you were pulling, and I forget where it even was. You had show, and it was different things that you could show. It may have been with the box and whisker plot, I'm not sure, but one of the things was show outliers.
Yeah.
And maybe this was an update that I missed. Is there a way that students can identify outliers with Data Classroom now?
Yeah, and so we did this after some direct conversations with the director of AP Statistics at College Board, and we've tried to mirror the methods that are in the AP Stats course, and I can show you that off of this graph. Over here, where the default is show dots, you can also choose to show outliers. And I also fear that this data set might not have anything that qualifies as an outlier. These look pretty normal to me. But if you go, you can choose which rule you want to use, the 1.5 IQR. And so that will identify any data points that are outside 1.5 times the interquartile region. Or you can do the more extreme, anything that's beyond 2 standard deviations from the mean. So those are even bigger outliers. But if I choose like outside 1.5 IQR, it is also going to automatically change you to a box and whiskers, because this is sort of traditionally where that is used. And so if I do that, oh, actually this data set does have some outliers. So we can see it is hiding all of the data that is not outliers. And it is the whiskers have been changed to 1.5 times the interquartile region. So the interquartile is the box, and then each error bar is 1.5 times the length of that box. And then you can see data points that are beyond that. Now, what you choose to do with those is up to you. And I always think it necessitates a degree of caution. And for example, like this data set, this was conducted at an Indian Agricultural Institute, a professional research setting. That's actual data that they collected. I don't think there would be any reason why you would exclude those outliers from your analysis. They're really not that extreme. And if you have confidence in the way that they're collected, even though the 1.5 IQR test, identifies them as outliers, I would absolutely not recommend throwing them out. But if you wanted to eliminate a data set or a specific data point, you can look at the row number here and say, like, I don't know, let me see if we have one that's a low row number, but row 192, right? If I go to the table, I can find row 192. If I show 500 rows per page, and I could go down to row 192, and I could exclude that from analysis by checking this exclude box over here. And, now when we go back to the graph, that data point is no longer there anymore. So that, that's what you can do. But again, I think use the ability to find outliers, or even the act of finding outliers, you use that with a bit of caution for sure.
Thank you.
Sure. You had a keen eye. You spotted the new thing that I did not include in my list of 4 new things. So good on you.
Well, I have students that ask me about outliers all the time, and and like you said, how do you identify those? They learn the term in their math classes, but they never really apply it, and so having a way for them to be able to identify those and to talk about whether, like you said, whether it's appropriate to remove those outliers or to keep them in, really has a lot to do with their confidence in their testing.
Yeah, absolutely. Absolutely. Yeah.
Hi, Aaron. It's Lawrence. I have a question about the switching between the data classroom and the U.
Yeah, go ahead.
If you remember, we spoke earlier in the fall. I have science research. I'm just starting to use this, and I have 9th, 10th, 10th, 11th, and 12th graders in my class. And I'm wondering, can a student switch between them themselves? So in other words, like a sophomore may be more comfortable with Data Classroom, but I found that the juniors kind of wanted more. So could they switch then to the U?
So, Lawrence, first, thanks for joining us. Good to hear your voice again. They cannot, because we sell those licenses separately. Now, there are high schools that are customers that have purchased a Data Classroom U package so that students can go back and forth between each, or in some cases, students can just use the university level package. If you're interested in getting some pricing on that, feel free to just drop me an email, and we can discuss that. We'd probably even be willing to let you trial that for the rest of this year, so you could, make an informed decision about how much you would actually like to use that with your high school students or not.
Okay, great. Because I'm not even really I'm not even familiar until a moment ago that there's a Data Classroom U, so I kind of would need to learn a little more about it. But I'm just guessing that my juniors and seniors will be more interested in that.
Yeah, and I, knowing a little bit about your school and the competition level of the science fairs that your research students are engaged in,
Right.
I wouldn't doubt that there will be some students who would get some use out of the expanded features in DCU. But yeah, drop me an email, and I'll get you set up with a trial and you can test it out.
All right, great. Are you or somebody else gonna be there at WestF on Saturday?
It won't be me, but yeah, our head of partnerships, Mark Ousley, is going to be there.
Okay, great. All right, thank you.
Sure. Okay.
Aaron, could I chime in?
Yeah, absolutely.
Hi. So similar, sort of in that same vein, and I'm fairly new to this, but having asked if students can't switch back and forth, and of course today your demonstration went to you to show how you could take it out to R or Python.
Mhm.
Then we went back and saw that like the descriptive statistics and everything are available in the non-U version. Could you just give a quick rundown of some of the other things that are different between the two?
Yeah,
Just very briefly.
the biggest difference is that bridge to R and Python coding. That is by far the biggest. The other difference is the statistical testing includes non-parametric options and a few others. So right now we're looking at the K-12 version. And so statistical tests that exist in the university version are the non-parametric equivalents to t-test and ANOVA, as well as the ANCOVA, the analysis of covariance test, and then also the multiple linear regression. So those are all available in the university package and not in the standard K-12.
Okay, great.
Yeah.
Thank you.
Sure. All right. Well, we are about out of time. If there is a last minute question, I'm happy to take it. And if there's not, let me just really quickly put up my contact information. Yeah, so if anyone has any follow-up questions about something you saw today or something you didn't see, you can always reach me at Aaron@DataClassroom. That's AARON at dataclassroom.com. I'm happy to take any questions that you might have offline as well.